Okay, so let's proceed to part 2 of our course, which is the numerical methods. So what is numerical methods? So numerical methods are used to solve problems on computers by numerical calculations, giving a table of numbers and or graphical representations. So these are techniques by which mathematical problems are formulated so that they can be solved with arithmetic and logical operations. So numerical methods are the methods used by a computer in calculating. So errors. What are errors? Errors show how far off a value is from its true or actual value. So that is error. So absolute error, we have two types of error. That is the absolute error and the relative error. So absolute error, the magnitude of the difference between the exact value and the approximation or the measured value. Exact or actual and approximation or measured. And relative error naman expresses how large the absolute error is compared with the total size of the object you are measuring. Ibig sabihin, absolute value over the measured value. So, let's have examples here. Example number 1. A procedure is supposed to yield 1.0 liters of solution and you obtain 0.9 liters of solution. Compute for the absolute error. So yung absolute error natin, the formula is equal to the actual. So, ano yung actual value natin? That will be 1.0 liters. And then minus our measured value, C, 0.9 liters. Therefore, our absolute error is equal to epsilon yung ano niya, yung symbol niya. So, absolute error is equal to 0.1 liters. Okay? So, for example number 2, a driver's speedometer says his car is going 60 miles per hour when it's actually going 62 miles per hour. So, compute for the relative error. So, ano si 60 miles? 60 miles is our measured. Okay, so this is our measured mph, measured in the speedometer, and our exact value or true value is 62 mph. Sorry. This is our exact value. So, what is the formula in getting the relative error? So, that is equal to absolute error all over the measured value. So, this is equal to, okay, formula for absolute error, that is exact. So, that is 62 mph minus our measured, that is 60 mph, all over the measured value. So 60 mph. So this is equal to 1 over 30 or 0.033. Okay, so this is our relative error. Um, i-add ko lang yung percentage error. So percent error, formula for percent error is equal to, ayan, symbol niya is ganito. Formula for percent error is equal to the relative error times 100. Okay, 100%. So this will be equal to, what is the percent error of example number 2? This is equal to 0.033 times 100%. That is equal to 3.3%. So ito ngayon yung percent error niya. Okay, so those are examples of error computations. So rounding and chopping. So assume a computer that can store 7 significant digits. Okay, so when we say chopping, for example, dito natin chinap. Okay, ang ginagawa sa chopping is ino-omit niya yung um, remaining digits. So if you write this down, matitira lang will be 4.24 242,857. Take note yung last digit niya is 7. So that's what you do in chopping. You disregard the numbers on the right of kung saan ka nag-chop. Okay? Sa rounding naman, okay, same dito rin natin siya i-slice. So this one, what will happen to our number is magiging 4.242,858. Okay? So nag-round up tayo. Since 6 ito, 5 above, mag-add 1 ka dito sa last digit mo. 4 below, stay lang, ganun lang, 5, 7. So, since 5 above to, nag-round up tayo. Okay? So, which is a better choice? Rounding is a better choice since the sign of error can be either positive or negative, leading to smaller total numerical error. Whereas error in chopping is always positive and adds up. Okay? So, mas maganda na ginagawa natin is rounding kesa kay chopping. Okay? To reduce yung error na mangyayari. Okay. So, we have computer errors in representing numbers. So, number representations na ginagamit ng computer is napag-aralan nyo sa digital electronics. Those are the ones and zeros. Okay? So, modeling errors. When a practical problem is formulated into a mathematical language, it is almost always necessary to make simplifications. So examples of modeling errors include leaving out less influential factors, for example, no air resistance in falling for physics, or using a simplified description of a more complex system. Okay? So instead na meron tayong kahit konting-konting air resistance when we fall, we assume na walang air resistance when we fall to make the solution simpler and easier. Okay, so those are modeling errors. Next are methodological errors. The conversion of a mathematical problem into a numerical one is also a source of errors. Care should be taken to control these errors and to estimate their magnitude, and thus the quality of the numerical solution. So, nangyayari din yung pag-convert natin ng mga word problems into mathematical equations. So, truncation or chopping errors result from using an approximation in place of an exact mathematical representation. Example of this is the Taylor series, ganyan. Yung mga series na sinasummation na lang natin. Okay? And then, another is discretizing error results when a continuous quantity is replaced by a discrete approximation. So parang when we approximate, mas meron talagang error na nangyayari. Okay? Kaysa sa exact na value na kukunin natin. Okay? So next, meron pa ba? Okay, meron pa. Errors due to initial values. So the initial values of a numerical computation can involve inaccurate values or measurements. When designing the algorithm, it is important to keep in mind that the initial errors must not accumulate during the calculations. So, sabi nga, yung konti na naiipon is nagiging malaki yung impact. So, we should avoid that. Okay? So, sa simula pa lang dapat wala ng errors. Okay. And then round of errors. Round of errors result from the omission of significant figures. So those are the kinds of computer errors in representing numbers. So that is the introduction of the numerical method. Okay.